Assalamu alaikum. I will continue solving the free response questions for grade 6 advanced term 3. Question number 10. A town provides rectangular recycling bin for each household. The volume of each bin is 3,840 cubic inches. Is the height of the recycling bin greater than 1 foot? Write an argument that can be used to defend your solution. So first, let's keep in mind that 1 foot is equivalent to 12 inches. So this is a key information will be used later. Then let's focus on what is given on that question and what is missing. What's given is the volume. The total volume is given. What is missing is the height. So to find the height, as I explained in the previous part, we said always we're going to reverse the operation or the process. We're going to undo the operation. When we find volume, we multiply the 3 dimensions. But now when volume is given, I will be dividing. I'll be dividing the volume by the product of the other dimensions here. So H is going to be 3,840 divided by the product of 20 and 12. So 20 times 12, you need to multiply it first, and then you will complete the division problem. Make sure that you are dealing with the same units. So here cubic inches, here as you see the length is given in inches, the width as well. So the answer for that problem is going to be, after multiplying and dividing, 16. So the height is going to be 16 inches. Now the question is it greater? Is the height greater than 12 inches? Well, clearly yes. 16 is greater than 12. That means the height is greater than 1 foot. Question 11. The loaf pan shown is shaped like a rectangular prism. It will be filled with the batter to 2/3 full to make a loaf of a bread without overflowing while baking. How much batter would it be, or would it take, to fill the pan 2/3 of the way? Write an argument that can be used to defend your solution. Well, firstly, I'll be finding the volume of that pan. The volume is going to be 3 times 5 times 9. The length times the width times the height. The answer is going to be 3 times 5 is 15 times 9. The answer is going to be 135 cubic inches for sure. Cubic inches. Now, keep in mind that not all of the pan will be filled. Only 2/3 of it. Only 2/3 of it. So the second step is going to be multiplying 2/3 by 135. When you multiply 2/3 by 135, the easiest way is sometimes to multiply then divide, or you can divide 135 by 3 then multiply it by 2. Both methods is going to give you 90 cubic inches. Question number 5. Lou wanted to determine how much his friends pay for video games. He surveyed them using the question, how much did you pay for the last video game you bought? The responses were 29, 45, and so on. How many more games cost between 30 and 39 than between 40 and 49? So let's focus here on the main request in this question, which is how many more? How many more games? Whenever you see a comparison form, how many more, how many less, how many greater, how many smaller, directly subtraction should come to your mind. So you need to keep in mind that we will be subtracting. So now I'll be finding the values between 39 and 30 and 39 and the number of values that are between 40 and 49, as you see here. So you will start counting how many values do we have between 30 and 39, and how many values do we have between 40 and 49. So just count. Just count using this way. You know, this is the best way to eliminate whatever you count. So the values here are 5 and here are 2. Then I'll be subtracting 5 minus 2 to get the answer. So the answer is going to be 3. Now let's introduce that easy question. Provide a data set that can be represented by the histogram shown. Well, in histogram, on the horizontal side, you will be seeing the categories or the values of the data set. And vertically, you're going to see the frequency. For example, between 20 and 29, we have 4 values. Between 30 and 39, we have 5 values. Between 40 and 49, we have 3 values. So all what you need to do is just to list values from your own according to the frequency value. Let's find out. For example, between 20 and 29, we see that we have 4 values. So let's say 20, 21, 23, and 28. These are values between 20 and 29. Okay? Of course, you won't all have the same answer. Here, the answers will vary. So there is no one unique correct answer. Now, let's continue. Values between 30 and 39, we should have 5 values. So let's say 31, 32, 34, 37, and 39. 1, 2, 3, 4, 5 values. Now, values between 40 and 49, we should have 3 values. So let's say 41, 43, and 45. These are values between 40 and 49. Now, values between 50 and 59, we should have 6 values. So let's say 50, 51, 53, and let's say 57, 57, like 2 values, the same, 1, 2, 3, 4, 5, and finally 58. At the end, let's check the values between 60 and 69. we have only one value. The frequency is 1. That means we have only one value. Let's say 62. So this data set could represent the histogram. Question number 5. The cost of tents on sale at sporting goods store are as follow. Use the range and in quartile range to describe how the data vary. Whenever you are asked to find the interquartile range and the range, you need first to arrange the data from smallest to greatest. So this is the first step. Let's arrange the data from smallest to greatest. The smallest value here is 64, then 66, and we have two values. And then we have 67, then 69, then 70, and 72, two values, and finally 78. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 values. Second step is to divide the values into two groups, into two equal groups. So this is the first group and this is the second group. The number in the middle, of course, we're going to have a number in the middle because the number of the values is odd. The number of the middle is going to be the median. Then we need to find the Q1 and Q2, quartile 1 and quartile 3, 3. So actually Q2 is the median. So to find Q1, you need to find the value here in the middle. But in the middle here, I have two values, not only one value. If you have two values, then you need to add them and divide by 2. If you have only one value, then in this case, this will be Q1. But here, as you see, we have two values, so I'll be adding them and divide by 2. For sure, the answer is going to be 66. So this is the value of Q1. And for Q3, we are going to do the same. We will look for the value in the middle, but since we have two values, I'll be adding them. And then I'll divide by 2. So the value obviously is going to be 72. Now, let's find the range. The range is to subtract the minimum from the maximum. So always maximum minus minimum, the greatest value, which is 78, minus the smallest value, which is 64. So 78 minus 64, which is 14. So this is the range. Then the inquartile range, or IQR, so IQR is the inquartile range, is Q3 minus Q1. So 72 minus 66. 72 minus 66. The answer is going to be 6. So this is how to find the range and IQR. Now let's solve the last question in the written part. The table shows the number of points scored by the 7th and 8th grade girls basketball teams in each of their games this season. Construct a box plot to represent the data for each team, then use the box plots to compare the data. So that question is considered to be lengthy somehow, but if you write well-organized details, it will be very easy. So as you see here, we have two teams, 7th grade team and 8th grade team. First, I'll be ordering or arranging the data from smallest to greatest for each team. So I'll be writing two lists for each team. Then, for each team, we will be finding Q1, median, and Q3. So after you arrange the data from smallest to greatest, as I showed you in the previous question, and this is very important, you will be finding Q1. So let's first work on 7th grade. 7th. Q1 will be 29.5. And the median is going to be 34.5. Finally, the Q3 is going to be 37. So, as you see here, I found Q1, median, Q3 for the 7th grade. Again, don't forget that data set should be ordered from smallest to greatest. Then I'll find the range. The range is always the greatest value minus the smallest one, minus the smallest value, which is 27 here. So 40 minus 27 is going to be 13. And the IQR, the inquartile range, is going to be 37 minus 29.5, which is 7.5. So we are finding Q1, Q3, all these, the median, because these are the elements that will help us to draw the box plot. Without these elements, we can't draw the box plot. Okay? Then I'll be doing exactly the same, but now for the 8th grade team. So now we are going to work for the 8th grade team. Q1 is going to be 38.5. And the median is going to be 41.5. Finally, Q3 is going to be 44. Then I need to find the range for the 8th grade, which is 47. The greatest value is actually 47, as you see, minus the smallest value, which is 34. So the answer is going to be 13. And the IQR will be 44, Q3 minus Q1, so 44 minus 38.5, which is 5.5. Okay, after finding these values, we will be graphing the two box plots. So now I will draw the box plot for each team. So let's start first with the 7th grade team. You need first to draw a number line. As you see, the number line starts from 20 and ends with 50. Okay? But actually, this is not unique. This is not the only one. Of course, you can create your own number line, but it should, of course, fit the data set you have. So let's start with the values that I got previously for the 7th grade. I found that Q1 is going to be 29.5. So let's find the 29.5. So this is 26, 27, 28, 29. 29.5 is going to be here. So I will make a point here in the middle. Okay? And then I'll graph or I'll plot the median, and then Q3. The median is going to be 34.5. 34.5. This is 35. 30, 34 is here. So 30, 34.5 is going to be in the middle between 34 and 35. So here it is. Okay. So, and then Q3 is going to be 37. Here it is. So 35, 36, 37, here it is. So these points are essential, very essential to make a correct box plot. Q1, median, Q3. Then I'll start making my box this way. I will make small lines this way, small vertical lines, and then I will join them this way. Okay? So this is the box. But after you do that, you should plot the maximum and the minimum. How? The minimum in 7th grade team, the minimum value is 27. So here it is. Here it is. Then you will connect the minimum with a line, with a horizontal line, and it should reach the box this way. And for the other value, which is the maximum, we need to plot the maximum. The maximum is 40. Here it is. And then connect the maximum with a line segment this way. So that is the first box plot. Now let's draw the second box plot, the 8th grade team, for the 8th grade team. The same way. First, you need to plot Q1, median, Q3. Q1, median, and the Q3. Q1 is going to be 38.5. So I'll be working here because I don't want my boxes to overlap or to cross. So I'll be working on that area. So Q1 for the 8th grade team is 38.5. 39, 38.5. So it is somewhere here between 38 and 39. Okay, so this is a Q1. The median is 41.5. This is 41, this is 42, so it will be here in the middle. This is the median. Then we will draw or plot Q3, which is 44. Here it is. Here it is. Let's draw the median one more time, 41.5. 40, 41, here it is. And then I'll make small line segments, vertical line segments this way. Okay? And then I'll be connecting or completing the box, the shape of the box this way. Okay. Then after that, we need to draw the maximum and the minimum. The maximum is going to be 47. So here it is. 46, 47. Just join the maximum point with a line segment that reaches the box. And then the minimum is going to be 34. So here it is, 35, 34. Here it is. This way. And that's it. We have graphed the two or constructed. We have constructed the two box plots. Last step in that question, let's compare between the data. After drawing the box plots for each team, we have noticed that the 8th grade team shows more consistency than the 7th grade team in the middle half of their data. What do I mean by that? What do I mean by that? Which means the 8th grade team has more similar scores in the middle compared to the 7th grade team. So this is a clear explanation or conclusion you can use to end your work. Thank you for watching. Hopefully you're gonna find it useful. I'll be glad to hear from you, your suggestions and your comments. Assalamu alaikum.